The entity data model is important enough that it's well worth the time getting to know how it works and how to make the best use of it. The biggest benefit of using a model is that databases are rarely designed for easy use by applications, even where the application developers design the database. Instead, well-designed databases support maintenance, security, performance, and scalability, and those features aren't always consistent with an efficient application design. At design time, you'll most often work with the entity data model in the Graphical Designer in Visual Studio, which provides a great way to see, understand, and modify the model. But all the details of the model, including how it appears in the designer, are stored in a .edmx XML file. You don't necessarily have to understand every detail of that XML, but it's helpful to learn enough to know what Entity Framework is doing behind the pretty designer. And as you get deeper into the Entity Framework, you'll find that the designer doesn't support every feature that the entity data model makes available. So sometimes you have to get your hands dirty with the underlying XML. When you build a project containing an entity data model, Entity Framework breaks out the XML in the .edmx file into 3 separate XML files, one each for the conceptual and storage models, and another for the mappings. And by default, embeds those 3 files in the project assembly. This provides each file available at runtime as Entity Framework dynamically provides objects and responds to data access requests. The end result of the creation and implementation of the entity data model is that application developers don't have to know anything about the underlying data store that serves the application with data. All they need to know and understand is the entity data objects that magically provide data and let the application modify data. The Entity Framework then takes care of all the work of connecting to the data store, generating commands and executing them, providing entity data objects to the application, and processing changes to the data. In this course, you'll learn about how the entity data model is structured and works so you can make effective use of it within applications. At application runtime, Entity Framework works with 3 models: conceptual, storage, and mapping. The conceptual model is really the actual entity data model, providing what Entity Framework needs to create the entity data objects for that application. It contains structural information about each entity that it provides, including properties and their data types, associations, and collections. The storage model represents the database schema, with information about the tables and views accessed through Entity Framework and their fields, data types, and the relationships between the tables. On the surface, it may seem like this is the same information as in the conceptual model, but the two can be structured radically different, particularly if you start with an existing database and make extensive changes to the conceptual model for easy use within the application. That's really what it's designed for. This allows a decoupling between the design of the conceptual model and the schema of the database, letting you use powerful schemas for data storage and object hierarchy designs for your entity data objects, so that the limitations of one don't affect the usefulness of the other. It really is a pretty slick system. And then the third model is the mapping model. This is the bridge between the conceptual model in the application and the storage model of the database. Entity Framework uses this mapping information in order to know what fields to use to populate object properties with data and where to persist data changes. This is the glue that binds the conceptual model to the storage model. So what I'm going to do now is show you how Entity Framework implements these models, how to use the designer to view and modify them, and help you gain an understanding about this important part of the infrastructure and how it works within an application. Although you can create an entity data model from scratch by writing XML code in your favorite text or XML editor, most of the time you'll be most productive using the wizards and designer in Visual Studio. Visual Studio and Entity Framework support 3 primary approaches to creating and implementing an entity data model and entity data objects: database-first design, model-first design, and code-first design. The approach you use depends on whether you're creating a model that is going to access an existing database, which mandates the database-first approach. If you create the database as part of the model, you'll use Model First. And if you want to build a model by creating POCOs, plain old CLR objects, otherwise known as .NET classes, then you'll use the Code First approach. So the first thing I want to talk about is creating a model using Database First design. Both the Database First and Model First approaches to creating an entity data model are directly supported by the Entity Framework item template in Visual Studio, strictly speaking in SQL Server Data Tools. For Database First, the Entity Data Model Wizard gives you the option of reverse engineering a database schema, selecting the tables, views, and stored procedures, as well as functions that you want to include, and then building the model from those objects. You can use the resulting model as is, or customize it to reshape the model that you use within the application just about any way you want. In this exercise, I'm going to create a new console application in Visual Studio and add a new entity data model that extracts the schema from the AdventureWorks LT database, using its tables and views for entities. All right, so I'm going to create the new project, do File, New Project, go here to C#, select Console Application. I can put the application wherever I want, and I'm going to name this AWLT. And I'll go ahead and click on OK to create it. Before I go any further, I want to add the latest version of Entity Framework to this project. I'll go down here to the Package Manager console, and I'll type in install package, hit tab, Entity Framework, and hit tab again. And that's the right one, and hit enter. All right, so it downloads it if it needs to and adds it to the project. All right, so now as a result, if I go over here to Solution Explorer, look at references, I now have these Entity Framework references. So now the project is set up to use the Entity Framework. Go to Solution Explorer again, right-click on the project, because I need to add the Entity Data Model now. I'll select Add New Item, and I'll go to the Data item right there. I need the ADO.NET Entity Data Model, and I'm going to call this one AWLT. And click on Add to create it. All right, and that fires off the wizard. So I'm once again going to use the EF Designer from Database because I'm using the Database First technique. I'm going to use an existing database and reverse engineer the model from that database. So I'll go ahead and move on. Now in this instance of Visual Studio, I already have a connection string to the AdventureWorks LT 2012 database. So I'm going to use that one right there. There's no reason to create a separate one. But if it didn't already exist in that drop-down list, then I could just click on the New Connection button, and that would open up this Connection Properties dialog box. All right, and there you can see the connection string. There are the three different models that Entity Framework is going to build as a result of this process. And then here's the connection string to connect to the SQL Server database. So that's that two-part Entity Framework connection string. It needs both the metadata information, which contains the models, as well as the connection to the underlying storage engine. Now, this is a name that's going to be used in the application, so I'm going to shorten that a bit and move on. All right, so in the Choose Your Database Objects and Settings page, the wizard has now gone out to the AdventureWorks LT database and extracted its schema information. So it now has a full list of the table of views and stored procedures and functions that are available within the database. And it parses out that information and creates these lists. And you can drill down into these lists and see the schemas and the tables within each one. Now initially, I'm going to check tables right here to check all of the tables. But then I'm going to unselect the DBO. So there's various ways to do that. But in this case, there are a couple of, this is essentially metadata information about the database, and I don't need to use that within the application. So there's no reason to include it within the model. But I will include all of the tables that are available as part of the Sales LT schema. And then similarly, I'm going to select all of the views. And if I expand that, you can see that within the Sales LT schema, there's 3 different views. And in this case, I'm going to use those within my model, so I need to include them in order to reverse engineer them from the database. All right, so here's the model namespace. I'm going to shorten that because that's a name that we use in code a lot. And it just makes it a little bit easier if it's a shorter name, and easier to find within IntelliSense when you're writing your code. Now I'm going to accept the rest of the defaults within this dialog box, but I do want to point out what the options are that you have because they affect how you create your model. So this first item here, pluralized or singularized generated object names, tells the model to attempt to correctly singularize the names of single instances of the entity objects and pluralize the names of collections. So this is a pretty nice feature. So entity sets, which are a collection of entity data objects, will be pluralized, but individual objects, such as customer, is going to be just singular, no matter what the name of the table is, however the pluralization or singularization is of the table name within the database. And then the second option here is include foreign key columns within the model. This gives you the option of including properties for any foreign keys for child entities associated with another entity. Now, version 1.0 of Entity Framework didn't offer this option, but there are a number of scenarios where you need to have access to the foreign key values within your application. So generally, it's best to include foreign keys within the entities, unless you're absolutely sure that you're not going to use them. If you're not going to use them, there's no reason to bloat the objects with that additional information. And then the third option here is import selected stored procedures and functions into the entity model. So what this is going to do is, if you have this checked, and if you include any stored procedures and functions here, then it'll automatically include those behaviors within the object. This eliminated a rather cumbersome, roundabout set of steps that you had to do in earlier versions of Entity Framework in order to import those pieces of code. Now it's much simpler with this option there. Now it's not going to apply in this particular case, but we'll see later how it does apply. All right, so that's everything I need to do for the wizard. So I'll click on Finish, and it'll go out, create that model, and populate it with the objects that it reads from the database. All right, and that takes a few moments, but the end result here is this model with all of the tables within the Sales LT schema, as well as all of the views. And you can see the views are kind of scattered about within the model. Now at this point, when you click Finish on the wizard, you may get a security warning dialog box that says something like, running this text template can potentially harm your computer. Do not run it if you obtained it from an untrusted source. Now that sounds kind of dire, and I didn't get that dialog box here. But it just means that you downloaded Entity Framework from the evil internet, and to be careful. So if you do get that dialog box, if you're sure about the templates you're using, if it's Entity Framework, then just click on OK and the dialog box will disappear. Now, one thing about this model, it appeared on the page, actually the error list right there, it appeared briefly when the wizard was done with its work. So here you have 3 warnings that concern the 3 views that I included within the model. The error message in each case is error 6002. The table view, whatever, in this case v get all categories, does not have a primary key defined. The key has been inferred, and the definition was created as a read-only table view. What happened here is that views in SQL Server don't have primary keys. It's just not part of what a view is in SQL Server. So the wizard had to create one for me. The reason being is that it needs to be able to uniquely identify each piece, each row of data from within that view. All right, now I'm going to talk a little bit later about how the model handles this, particularly when we start looking at the underlying XML. But for now, It's okay just to see that those warnings are there. They are warnings so they don't stop the code generation or anything. And you can move on and use the model.